Good morning everyone. Today we will proceed with ray optics. In last class we had seen many important concepts like dual nature of light, phenomena like reflection, refraction, total internal reflection and optical illusions. One of the optical illusions was left that you can see, and we'll start from here. So first you are expected to write about this, then I will make you understand. Okay, first write. Okay, from where you have left. After that you write, at dusk and dawn, at dusk and dawn, sun appears to be slightly, sun appears to be appears to be slightly bigger than normal. Sun appears to be slightly bigger than normal. Next point you write, we are able to see sunrise, we are able to see sunrise 2 minutes before, we are able to see sunrise 2 minutes before and sunset, sorry, we are able to see sun, just write like this, I am very sorry for this, rise को काट दो वहाँ पे, we are able to see sun 2 minutes before sunrise and 2 minutes after sunset. This should be the line. We are able to see sun 2 minutes before sunrise and 2 minutes after sunset. We are able to see sun 2 minutes before sunrise and 2 minutes after sunset. This is an optical illusion. Okay, this is due to refraction. See what happens. This is due to refraction. There are many atmospheric layers between sun and you. So if sun is at horizon, at dusk and dawn, sun will be at horizon, or during sunrise or sunset, sun will be at horizon. So these rays after refraction will be reaching your eyes. Okay, and line of sight is upward. Last class I had told you, if light is coming from upward direction, so the person will use line of sight like this. So rather than finding sun here, we will be able to see sun here. This is all because of refraction. Okay, so this is all because of refraction that we are able to see sun 2 minutes before sunrise. Means sun is at the horizon but you are expecting sun above that. This is all because of refraction. And you are able to see sun 2 minutes after sunset also. The same phenomena is responsible for the same. Now the second line, the second point, that size is slightly bigger than normal. For that I request you to see this, and here there are two slanted lines and two straight lines in between. So two straight lines in between, this is the first line, this is the second line. So are you able to see the upward line to be slightly bigger than the downward? Yeah, the first line, that is the upward line, is bigger than the second one. Yes or no? You must be expecting the same, right? But take it from me, both are equal. Both are equal. Okay, I am removing removing the dotted lines. Again you will see that the upper line seems to be slightly bigger. Why is it so? Why is it so? This is because of the inability of human eye. If some part is concised in a small area, then it appears to be slightly bigger. For example, sun at horizon is concised in a very small area. That is why sun appears to be slightly bigger, right? In the same fashion here, the first line, that is the upward line, is concised in a very small area or narrow area. That is why it appears to be slightly bigger, though the size is same as that of the downward line. Understanding this? So that is why sun appears to be blue, because appears to be bigger, because at horizon it is concised in a very narrow space. Okay, so I hope you have understood. So ये जो हल्का हल्का सुरूर है तेरी नज़र का कसूर है. So this is the problem of your eye and nothing else. Just try this question very quickly. These are previous year questions. 4-5 questions are there. We will be finishing within 5 minutes. So I want your response very quick. Okay, I have got some Dhananjay Pandey, Rohit Kumar, both have given the right response. Vikram Singh, yes, you are also right. Total internal reflection is the correct response. Okay. So option D is the right answer. Chhawa has also given the right answer, Chhawa Triveni. The second one, diffusion of light in atmosphere takes place due to. Sandeep has also given right response. Now try this question. Diffusion of light. Take it from me, if they are asking this, then they are asking at normal circumstances. I will give you a hint. Rayleigh scattering at normal circumstances. What should be the answer? This is the hint. Diffusion is Rayleigh scattering at normal circumstances, when the situation is normal. Rohit Kumar has given his response. Rohit, there is a slight error in your response. Rayleigh scattering at normal circumstances. You can go for the table also. Okay, Vikram, you have also gone for the same response as Rohit has gone. Okay, Rakhi has also given. Maybe there is problem in my teaching. Everybody is selecting the wrong answer. Okay, I have got the right answer. Chhawa, Sandeep Rai, Sandeep Yadav, Dhananjay, everyone has gone with wrong answer. Option D, water vapor. Right answer is dust particle. Option B, Rayleigh scattering at normal circumstances have dust particles in the atmosphere, because of that red light okay, scatters very less. When there is the situation of storm, now Rohit has corrected his response. When there is storm, etc., then water vapors or salt particles are there in the atmosphere. Okay, so whenever they are asking diffusion, it means the normal circumstances they are asking. Whatever the options you have selected are extraordinary circumstances, not normal circumstances, right? So option B is the right answer, dust particles. I hope you are understanding this. Try this question. This is a good question. Okay, take 1 minute to give the response. Okay, Utkarsh, Chhawa, Rakhi, all have come with their response and they are right. Rohit, Vivek Gupta, Yes, C is the right answer. And everybody has gone with the right response. Very good. Now see, they are asking about Dhananjay, you have gone for wrong response. Sandeep Kumar Yadav, your response is right. Now just see, size of sun at dusk. Yes, it appears to be slightly bigger than normal. Okay, so this is right. Color of the sun as dawn. Definitely the color is also impacted. It appears to be red. Okay. Ajit Kumar Rawat, Vikram Singh, they have also given right answers. Moon being visible at dawn. Moon being visible. Dhananjay, just take it from me. Moon is unable to send its own light, okay, because it has no light, right? It absorbs the light of sun. So when sun is there, it will be involved in absorbing the light of sun rather than reflecting. So when sun is gone, only then it reflects its light. So it is not what we say, optical illusion, that is refraction. It is all about the property of moon. And option D, twinkling. Yes, twinkling is also refraction, that is an optical illusion. Pole star being visible. It is asking about the visibility of pole star, nothing to do with the phenomenon like twinkling. Though the option seems to be confusing, but UPSC has not kept any option, okay, which will take option 4 and 5 together. So that is why law 4 and 5 is there in option B, but option 1 is correct, everybody knows. So there is no confusion type item there in your options. Okay, so option C is the right answer. Very good. Try this question. Okay, Chhawa has gone with the right response. Rohit Kumar is also right. Very good. Vikram Singh is also right. Sandeep Ray, please try to correct your answer. There is slight error. You have missed something. Dhananjay Pandey has also gone for right response. Sandeep Kumar Yadav, Rakhi, all have chosen correct answer. Option D, 1, 2, 3. Okay. Okay. Utkarsh Chauhan has also gone for option D. Very good. Okay. Now let's talk about mirrors. Okay. So we are talking about mirrors because we need to go for defects of vision, etc. So first we will understand mirrors and their uses, then we will proceed. Okay. So starting with plane mirror. So whatever I will be writing on board, that is notes. I won't be dictating for this. So next few minutes you are on your own. So this is what is a mirror. Okay. So a mirror has two sides. This side is known as shiny surface or front size of mirror, where you stand and watch yourself. And this side is painted surface, which is known as back side of the mirror. So your plane mirror, plane mirror is nothing but the mirror that you use at your dressing table or before leaving your house, okay, in which you find yourself as Shah Rukh Khan or Hrithik Roshan, or you find yourself like any other actress. So that mirror is your plane mirror, okay, dressing mirror. There is some property of this mirror, so we will just understand what are the properties. Property number 1 is, suppose you are x meter away from the mirror, okay, x meter away from the mirror. Then suppose you are here, then your image will be formed x meter behind the mirror. So here your image will be formed. Means if you are 5 meter away from the mirror, your image will be formed 5 meter behind. If you are 2 meter away from the mirror, your image will be formed 2 meter behind. Means if you will go away from the mirror, your size will appear to be smaller. If you are near the mirror, you can see your face very clearly. So that is what is meant. Second thing is, in plane mirror, virtual image is formed. In plane mirror, virtual image is formed. What do you mean by virtual image? I don't know. Virtual image is, it means the image is erect. Virtual image is when two rays actually do not meet. Okay, we should not enter in physics, just understand this. Erect. Erect means as I am appearing to you. For example, I am standing like this, my head is upward, my legs are downward. You are able to see me in exact position, right? That my head is upward, my legs are downward. My question to you is, image formed in your eye. Retina is the screen of your eye. So image formed in your eye is virtual or real? Please answer me in the prompter. I will discuss it after your response. So virtual image is formed, that is erect image is formed. Second thing is, there is a phenomenon called lateral inversion. Lateral inversion. Lateral inversion is a phenomenon in which right appears to be left and vice versa. Lateral inversion is right appears to be left and vice versa. Okay, we have got some response. Utkarsh, Chhava Triveni, virtual image is formed. Rohit is virtual image. Okay, Utkarsh says that virtual image is formed, which is then corrected by our perception. Okay, yes, logically you all people are right, but if you see, you all are wrong. So this is your human eye, right, and this is retina, the screen of the eye. Image will be formed here. So at retina, yes, Dhananjay Pandey has gone for right answer. Real image is formed. Real image is formed, but now the response has no value because I have answered you. Okay, you should have given the answer first. So real image is formed. Real image means inverted image is formed. So at your retina, my legs are upward and my head is downward, but there is a nerve that comes out of your retina. This nerve is known as optic nerve. This optic nerve goes to brain, in brain occipital lobe, that interprets that the object is inverted. Okay, so brain interprets the image that it should be erect rather than real, rather than inverted. So my image in your eyes are formed inverted. Okay, it is the brain which interprets it in the correct manner or correct way. If someone is finding myself to be inverted, then he should immediately visit to a doctor of a neuro doctor. Okay, because there is no problem in his eye or her eye, the problem is in the brain. Okay, आपका दिमाग खराब है अगर आपको उल्टा दिखाई दे रहा होगा. There is no problem in eye because eye is doing the perfect job. So real image is formed there. So this is all about plane mirror. There is a device called periscope that is used in submarine or you may say tanks. So this periscope is a device that is used to see objects in different plane. For example, you are at third floor and there are terrorists at fourth floor. Earlier there were no devices like drones etc. that security forces or any other forces can harness the benefit, but today they are. Earlier there was a device called periscope because it was used to see objects in different plane. For example, see here, periscope is like this device. Suppose that is Apple. Apple is kept at fourth floor and you are at third floor. So how you can see that whether something is there? So periscope will be this kind of device. If you have seen Tom and Jerry, okay, so Jerry uses periscope. There was one episode. I always think that I should put that screenshot, but I always forget. Okay, no issues. So now here is this, and there are two plane mirrors kept at 45 degrees. So the image comes from here. So 45 degrees, so there will be like this. 45 degree will be the angle of incidence and refraction. So this will be like this, and you will be able to see the object. So it is falling very straight. So it is working on the principle of total internal reflection, okay, TIR. It is working on the principle of total internal reflection where plane mirrors are used. So you can write here that plane mirrors are used to build periscope, okay, based upon TIR. This device, it doesn't mean that you should use this device anywhere, okay. Right to privacy is also a fundamental right you should keep in your head. Now we will cover spherical mirror. Again, copied from board. See, spherical mirror is of two types. First is this, okay, this mirror, and the second type of mirror is this. So this is the painted surface and this is the shiny surface. Obviously, clearly you can see in both cases. Here this will be the painted surface and this is the shiny surface. This mirror is known as concave mirror. We also call this mirror as converging mirror. I will tell you why. If you have slightest of confusion in finding whether this is concave or convex, let me tell you, try to enter the shiny surface of the mirror. Try to enter. So here you are trying to enter the shiny surface of the mirror, right? So you will find that you are entering in a cave. That is why concave. Here you try to enter the shiny surface. You will not find yourself to be entering in a cave. Convex. This is how you can remove your confusion or do away your confusion. So this mirror is just opposite of that, known as convex mirror, or it is also known as diverging mirror. Why it is called converging mirror? Because it converges parallel beam of light at a single point called focus. Focus is also the point where image is formed. When I call you, I want your focus here. Means what? I want your attention here. For example, the every beam is coming and it is getting converged at a single point. It means what? Suppose this is coming this way and this is coming this way. So everything is getting converged at this single point. Okay, that is why it is called converging. It converges all parallel beam of light at a single point. Image is formed at that point where two rays meet. Okay, the meeting of two rays lead to the formation of image. So that is why I have also written focus is also the point where image is formed. Is it okay? So this is what is the concept you should keep in your head. Actually, there are many ray diagrams on this even in your NCERT, that if object is at focus, object is at infinity, between center of curvature and that sort of thing is not required for us. I am teaching you this because I have two purpose here. First purpose is to make you aware with concept of focus, etc. Second is I have to teach you defects of vision. So if I will be talking about diverging lens or converging lens, then what should be the concept and applications of these mirrors. Okay, application is more important. That is why I am teaching you. Okay, otherwise there was no need. This is known as diverging mirror because it diverges parallel beam of light. That is it. We will write this much only. Now if you see what can be the applications of these mirror. Okay, so applications I am going to write. First, application of concave mirror, right? Application. So application can be at two places. You have to keep in your head. First, if we want to have image bigger than the object. So if you want to have image bigger than the object, this here you can use the you can have the application of this. And second, if we want to focus parallel beam of light, okay, if you want to focus parallel beam of light, so these two places can have the applications. For example, the shaving mirror, you want to have clear shave, so you want to see that if something is left or not. So shaving mirror should show you some bigger size because your eyes will not be able to see tiny hair follicles, right? So shaving mirror. Second is your dentist mirror. So dentist needs to have a very clear vision, else instead of removing this that tooth, he will remove something else. This happened to one of my knowns. And you want to focus parallel beam of light. So where you can use it? Torch, headlights of vehicle. If you won't use concave mirror, now it will diverge so much that its reach will not be there. Okay, it will end up to this distance, but you want that it should show you the entire picture of the road. So you try to converge the same. That is why it is used there. And if you want to see the application of this mirror, okay, so the application will have one slight observation, that if we want to have image smaller than the object, or if you want to have smaller image of the object, that is better. have smaller image of big object. That is better way of writing. Okay. So what can be? For example, rear view mirror of vehicles. You want to see the truck coming, you want the small image of the truck. You want like that only headlight should be appearing and you are guessing that whether it is the headlight of truck or bus or Land Rover. So that should not be the case. Okay, you will be prone to accident. So you want that what exactly is coming you should know. So that is why rear view image should show you the smaller version of that. It is also used as surveillance mirror or guidance mirror, whatever you say. For example, earlier there were no CCTV cameras. So how people used to surveillance mirror were at superstores. So at villages etc. they still use this. If somebody has entered the market, okay, what if he or she is putting something in the pocket? So you should see the entire small image that he is doing something with the pocket so that you can search that person later, right? So there is a one person who will be looking at the mirror all the time that what other people are doing. If somebody is putting it in the basket or the pocket. So this is the observance. So for that small image of the person should be formed. It is also used in your sunglasses. Because you want to see the entire landscape. You won't be like Arjun that only I want to see the bird because I have to just throw my stone on that, or put my arrow in the head. That is not the case. You want the entire landscape. Okay, so everything should appear to be smaller. The bigger mountains should appear smaller. And same is with telescope. So this is how you can remember, and these are the applications, few of the applications of these, right? So first copy this, then I will tell you about lens also here only. I will not do it. एक साथ दिखा दो सब. नहीं पॉसिबल. अच्छा बारी बारी सब. Okay. Now just see, we have two kind of lenses with us. This is your first kind of lens known as concave lens. Are you able to see from both sides you will be entering in a cave, so that is why it is concave lens. This is also slightly bent, okay, so this is concave lens. Concave lens has properties similar to convex mirror, okay, have similar property that of convex mirror. That is why it is also known as diverging lens. That is why it is also known as diverging lens. And this lens, this is known as convex lens, and this is known as converging lens, just because its property will match with concave mirror. So just the opposite. So it will Just copy this, then we will talk. Okay. Now just see the PPT. This is your concave lens. Okay, just see that the greenish line, the greenish parallel lines, they are getting diverged or not, they are getting away, they are not getting converged, okay, they are getting away. That is why it is called diverging lens. On the other hand, just see the converging one where the red ones are coming and they are meeting at a single point, that is known as focus. So that is why it is known as converging, and diverging because it is making it away. Converging means letting it meet at a point. So that is what is the difference. Okay. This all is because of refraction, because glasses will have different density or refractive index, we use the term, no issues. So understanding this, so this is what is the mirror and lens. So I have taught you so many things, but see what UPSC has asked and what kind of question it is going to ask. What is a zoom lens? This is the question and you have to try. Okay, I have got one answer. Rohit Kumar. Okay. Sandeep Kumar Yadav. Yes, Sandeep Kumar Yadav, you are right. Dhananjay Pandey, you are also right. Rohit Kumar, you need to see your answer. Your answer is wrong. Option A is not the right answer. Those who are thinking of it. If something can be zoomed, how it can be fixed? Just think on those lines, Rohit. If something can be zoomed, how it can be fixed? Yes, okay. Option B is the right answer. Variable focal length. Just see, this question was asked in 2008. That time, the camera you are having today was not that much, okay, but there was a facility of zoom. Okay, if you ever have used that camera, that phone, there was a facility of zooming by clicking on that. So zooming means what? You are changing the focus. That is why if you want to see the entire landscape, you just pull it in, else you pull it out if you want only to take the face of the person. Okay, that depends upon your needs. So zooming means what? Having different focal length. And Utkarsh, you are also right. So option B is the right answer. Because focus is the point where image will be formed. So you are just changing the focus. Because of that, the property of the image is getting changed. Okay, option B is the right answer. Now we will proceed with defects of vision. That is the last topic of ray optics. So we start with defects of vision, not vision IAS. Okay. So the first one is myopia. Okay. Let's understand what is myopia. Okay, very quickly. These are not, this is in NCERT. This can be asked, so I am teaching you. Your biology faculty thinks that this should be the part of physics. Definitely it is. That is why. So this is your human eye. So what happens? This is your eyeball. So this eyeball gets elongated a bit. Because of this elongation, the image is formed at this point, that is before retina. Right? Image is formed at this point, that is before retina, but you want your image to be formed at retina here, but image is formed here. So this is not right practice. Why? because if image will not be formed here, it will be a blur image. The image will not be very sharp, it will be a blur image. So for that, what you would like? You would like that image should be shifted here. Image should be pushed back. Pushed back means what? Image should be diverged. Okay, image should be pushed back. So that is why in this case a diverging lens or concave lens is used for correction. So in case of myopia, concave lens is used. So suppose this is what is the lens. Parallel beam of light is coming, it is getting diverged and it will meet at retina. So image is formed like this. Okay, so it is getting diverged and meeting like this. So myopia can be corrected using concave lens. Okay, so you want to write about myopia, just write in one line. But before that, let's see this one also, the second one, hypermetropia, so that we can write together. So what is happening? Hypermetropia, image is formed at this point, okay, but you want your image at retina here. So what you want? You want shifting to this side, means you want to pull it back, means converging. Okay, so you want to pull it back, that is converging mirror you want. So that is how you will start. So for that, hypermetropia, you will have a converging mirror, yani convex mirror. So this is for hypermetropia. This is for myopia. So image is formed on retina. So this is hypermetropia, this is myopia. Now see what is happening. In myopia, since image is formed in front of the retina, so the person is unable to see nearby objects very clearly. Okay, the person is unable to see nearby objects clearly. Okay, so correction is concave lens. So write myopia or nearsightedness. It is also called nearsightedness. Right, myopia or nearsightedness. Right. Due to the elongation of the eyeball, image is formed in front of the retina. Due to elongation of eyeball, image is formed in front of retina. Okay. Correction, concave or diverging lens. Correction, or just in one line also write, because of which person is unable to see distant objects. Because of which person is unable to see distant objects. Now write correction is concave or diverging lens. Just write due to elongation of eyeball, the image is formed in front of retina, because of which person is unable to see distant objects clearly. Because of which person is unable to see distant objects clearly. Person is unable to see distant objects clearly. Correction is concave or diverging lens. Next you write hypermetropia or farsightedness. Ray diagram you want to make, you can make these two ray diagrams if you want, whatever is on the board. First is of myopia and second is of hypermetropia. Just I am giving you 1 minute, draw it. Hypermetropia or farsightedness, the name. Okay. So hypermetropia will just be opposite of myopia, that you can write by your own. Okay. Leave few lines and after that you write a person may may suffer from both myopia as well as hypermetropia. A person may suffer from both myopia as well as hypermetropia. A person may suffer from both myopia as well as hypermetropia. Correction is bifocal lens. Bifocal lens has both concave and convex lens in it. Correction is bifocal lens. Now just see astigmatism. So in astigmatism what happens? See, image should be formed at retina, but here eye is unable to match horizontal and vertical lines clearly. Okay, horizontal and vertical lines are not matched clearly. Because of that, there are multiple foci or multiple focal points. Okay, just see this. Light should meet here, two light beams should meet here, but the vertical and horizontal lines are not meeting very clearly. So because of that, there are multiple focal points or multiple foci, and if multiple focal points will be there or multiple foci will be there, what will happen? Multiple images will be formed. Okay, so you will be able to see 3 images or 4 images of one object. एक एक के चार दिखाई देते. Last year when it was a traditional classroom, few of the students always say, sir, it is the condition after boozing. Yeah, that may be the condition, but for astigmatic people, means those who are suffering from astigmatism, it is always the condition. When your hangover is gone, you are able to see one object to be one only, but these people see one object to be 3, right? So that is what is the problem in astigmatism, right? So please write astigmatism. Due to distortion of curvature of eye, due to distortion of curvature of eye, multiple images are formed. Multiple images are formed. Multiple images are formed, right? Light focuses on multiple focal points. Light focuses on multiple focal points due to inability of eye to fix horizontal and vertical lines clearly. To fix horizontal and vertical lines clearly. To fix horizontal and vertical lines clearly. Just in one point you write myopia, hypermetropia and astigmatism. Myopia, hypermetropia and astigmatism are collectively called as refractive errors in eye. Myopia, hypermetropia and astigmatism are collectively called as refractive errors, because using refractive lenses you can correct them, and this is due to refraction. So, refractive errors. And the last is cataract. So, what is cataract? Cataract is the defect of old age people. What happens with age? There is formation of cloud on the surface of the eyelid. Okay, whatever there is a clouding on the lens. Okay, so when there will be clouding on the lens, initially you will not be able to recognize blue color spectrum, but with time that clouding becomes opaque because pus etc. enter there, so that becomes yellowish, and you will not be able to recognize various colors, and if untreated, if remain untreated, it may lead to blindness also. So, only treatment is that remove that clouding or that layer from the surface of the eye. Okay. So, please write this cataract, there is nothing much. It is clouding of the eye lens. It is clouding of the eye lens due to age. It is clouding of the eye lens due to age. Right. Initially, the person is unable to recognize blue color. Initially, the person is unable to recognize blue color. But when the clouding becomes opaque, person may turn blind. Person may turn blind. Person may turn blind. Only correction is surgery. So, correction is surgery. Correction is surgery. So, please try this question. Okay, have you read the question? Defect of color blindness can be. Okay, I have got answer from Dhananjay and Chhawa. Vikram, Utkarsh, Sandeep, Rohit, everybody, yes. D is the right answer, none of the above. Very good. So, you people are doing very good. Now, just see, color blindness is because the because of the defect of retina. It is not the defect of eyeball or eye lens, right? If the defect is belonging to eye lens or eyeball only, then the glasses can be used. If the retina is problematic, how can glasses cure the disease, right? So there are special devices nowadays that can do the purpose, and this is due to issues with the cones of human eye, right? You remember cones in last class we have done, and this is X-linked recessive disorder. In biology you must have been taught about this. Okay, so this finishes our ray optics. Now we are here to start with agenda of the day. So we'll try to finish this thing, but take it from me that it will be difficult for me to finish everything, but my idea would be to finish at least electric current today, and we will also try to finish latent heat if possible. If time will permit, we'll cover latent heat as well, and after that we will proceed with the other concepts in next class, and we'll start chemistry in next class. So these things will only have some applications in understanding your technology or current developments. Otherwise, if luck is there with you, you will get questions from these topics also. Cosmic physics will be interesting. Okay, no issues. Let's start with electric current. So what is electric current? Electric current is nothing, flow of charge. Yes, flow of charge is your electric current. Right, so electric current is nothing but your flow of charge. So if you want to write, you can write electric current is flow of charge. Else I am interested in this Ohm's law, where I have to deal with some concepts. So till break, okay, break will be only of 2 minutes, as you know. So till break you are dependent upon board. Whatever I will be writing on board, that is your notes. After the break I will be dictating. So Ohm's law is voltage equal to current into resistance. In short form they write V equal to IR. V equal to I, voltage. Current everybody must have, okay, must have faced the shock of electric current. So this is nothing but your flow of charge. Flow of charge. Voltage is measurement of power source. I will not be talking about potential, okay, higher potential, lower potential, that flow of current will be from higher to lower potential, because that is not our concern. Okay, we are not interested in hardcore physics. It is general science, so general physics will be the agenda. You try to understand in layman terms. So measurement of power source. You can understand in other word, higher the voltage, okay, more will be the current. Yes or no? Like you go to a shop, they say that this is 24 volt battery and this is 20 volt battery. You will come to know that 24 volt is having more power, it is more powerful. And resistance is hindrance or opposition in flow of current. So it is resisting something. How it is resisting, we will understand. So it is resisting. How? Let's understand. Suppose this is tunnel A. Okay, let's make bigger tunnel, no issues. And suppose this is tunnel B, and suppose this is tunnel C. Tunnel A, tunnel B, and tunnel C. Your height is around these two tunnels. Okay. These two tunnels are of equal width and these two tunnels are of equal length. Okay. So, if I ask you to choose which tunnel, okay, you have to traverse through any of the tunnel, that is the condition. You have to travel through A, B or C, means you will have to choose any one of them. So, which tunnel you will prefer? If I were you, I will go for tunnel A. Why? Because the height of the tunnel A is more than my height, and second, this length is smaller as compared to this. So, here the length is also smaller and the height is also more. So, I will be considering that tunnel. So, this will be my first choice. If anyhow I am not getting this choice, I will go for this choice. Why? Though the height is matching with me, but the length is lesser than this one. Yes or no? So, this will be the least preferred tunnel for any person, because this is offering me more resistance. Why? This is of same height, so I may be hit by the walls or I may hit by the corners of the tunnel. So, I can say that resistance is directly proportional to length or not. If the length of the tunnel is more, I am not liking it. Similarly with the current, if length of the wire will be more, I can write in this term or not. If the length of the wire will be more, resistance will be more. So, both are directly proportional. Yes. Why I am preferring A over C? Because the height is more. So, I can also say the resistance is inversely proportional to area of cross section or not. Means this one, area of cross section. So, definitely it is inversely proportional to area of cross section. Yes or no? Because this was having more area. So, that is why I am having that one. If I merge these two, I will get R equal to rho L by A, where L is length of wire and A is area of cross section, and rho is nothing, you can write X also, property of material. Where rho or X, whatever you write, is property of material. For example, what come may, this duster will not allow electricity to pass through it, right? That is the property of that material. But if duster is made up of iron, definitely current will pass through it. So, that depends upon the property of material also, that whether the resistance will be high or resistance will be low. So, first you copy this. I hope you are understanding this. Okay. Now, based upon the property, what are different sort of material we are having, right? So, based upon the property of material that I have written over here, there are four various differentiation. First is your conductor. Next one is your insulator. Next is your semiconductor. And the last one is your superconductor. Conductor has some property. So, what property conductor is having? Let us understand. it offers less resistance. It offers less resistance. Because of that, what happens? There is ease in flow of current. Okay, ease in flow of current. So what happens? Lesser resistance initially. This point is very much important. Whatever I am writing here, initially. With time, resistance increases. Increases, reflected in heating of device. So this point you need to ponder very clearly. Ki initially there will be very less resistance, but as the time progresses, definitely there is heating of the device. Why? Because the resistance increases, or vice versa. There is a relation in this. Insulator, it offers infinite resistance. So since infinite resistance is there, current can never pass. So current can never pass through insulators. This is what is the idea. Semiconductor, just opposite of the conductor, it offers slightly more resistance than conductor. Initially. With time, resistance offered decreases. This is because of band gap etc. thing. We will not enter in the chemistry of that. Just understand that it will decrease. Because of this, semiconductors have huge applications or enormous applications in electronic industries. Okay. And the last one is superconductor. Superconductors offer almost zero resistance. Okay. So it means they can offer zero energy loss, because heating of device is what? Energy loss, or resistance is what? Energy loss. If you are fighting with someone, means somebody is offering resistance, either verbally or physically. So what is happening? You are wasting your energy. So if resistance is almost zero, so energy loss will be zero. But unfortunately, they are active only at sub-zero. Sub-zero means less than 0 degree Celsius temperature. So that is not feasible to use superconductor, because if something is used, are you getting this? Something is used less than 0, so you need to have cryogenic infrastructure that will also require energy. So energy saved and energy consumed will be on same parameter. Maybe you will be in loss also, because keeping it at sub-zero will require more energy. But recently we have a dramatic game change, that silver at nanoscale, it is at research level, silver at nanoscale reflects superconductivity. This is what is there. So what is nanoscale? Let's talk. Nanoscale means scale of 10 to the power minus 9 meter to 10 to the power minus 7 meter. It will be taught by the faculty of science and technology. Okay. So he will be taking nanotechnology, but if you want to understand very quickly, this is the scale of 10 to the power minus 9 meter to 10 to the power minus 7 meter, means 1 nanometer to 100 nanometer. Just pull out your hair follicle and try to divide it 100 times, okay, along the diameter. The 100th part will be the nanoscale that you will not be able to see. So nano is very small. So at that smaller level, silver particles are showing superconductivity. So it is only at lab level. Application to the daily life is still not possible. This is what I meant. Okay. Now we will talk about series and parallel. See, insulator etc. is a very common thing, so I have written it very simple words. If you want more explanation, you can tell me, else I find that this is okay. The language was simple, you can clearly understand. Now series and parallel. Okay, my purpose is not to teach you series and parallel. Okay, this is because I want to teach you fuse. So for that we need to understand at least what is series and what is parallel. So we will not be talking in terms of potential difference, okay, or we will be talking in very simple terms. The explanation of this is partially right, but it is okay. That will work for we people because there will be no numerical etc. that will be testing your compatibility or your understanding of circuits. Okay, you are not going to be a engineer or anything else or electrician. You are going to be an administrator. Suppose this is your house and this is a bulb at your house. This is the circuit of your house. This is the power source and this is the bulb. So you belong to a poor family and this is how everything is happening. Only a bulb. Your friend in the colony, he is also poor. His house is also having bulb. So this is also having bulb. So two bulbs in two houses, one bulb each. No fan. Okay. Then Modi ji came with Yojana of Garib people, launching Pradhan Mantri Pankha Chalao Yojana. Under that, fan was distributed, so you got a fan. So what you did, under Pradhan Mantri Pankha Chalao Yojana, you got a fan, and this fan was added in the circuit by you. So you have added the fan like this. Your friend did one thing, he brought some wire from the market and he added fan like this. Okay, he added fan like this. This connection is called series connection and this connection is called parallel connection. why we are concluding on this, okay, why we are saying this. Okay, suppose 5 ampere current is coming out from it. Ampere is the unit of current, those who are not knowing. So 5 ampere current is coming. So if you see, from the bulb 5 ampere current will be flowing, and from the fan 5 ampere current will be flowing, because there is only one route, so same current flows through the circuit. So you can remember series like this. Same current flows through all devices in the circuit. Okay, and here just the opposite you can write, same current will not be flowing. Suppose this is again 5 ampere current is coming. So 5 ampere current will have two routes to travel, this route and this route. Suppose this route took 3 ampere and this route was given 2 ampere. So are you able to see different currents are flowing through different routes, through different devices. Through fan 3 ampere, through bulb 2 ampere. Here through fan 5 ampere, through bulb 5 ampere. So different currents are flowing through different devices. So this is what is your parallel connection. This is what is your parallel connection. My question to you is, your household is having series connection or parallel connection? Your household is having series connection or parallel connection? Okay. Yes, I have got one answer, Dhananjay. Yes, you are right, parallel connection. So parallel connection is what is done at our house. Why it is so? Just understand. Suppose Pradhan Mantri Sanjay Kumar Yadav, okay, Chhawa, Rohit, everybody has given the right response, parallel, right. Suppose under Pradhan Mantri Pankha Chala Yojana, the fan you received was faulty. So it stopped working. So fan stopped working. So if some device stops working, it acts as insulator and it will offer you infinite resistance. Okay. So it will offer you infinite resistance. So what happens? 5 ampere current will go, it will come to the bulb, fan will not allow it to pass further. Because of that, no devices in the circuit will be working. Understand this once again. Fan stopped working, so fan will be offering you infinite resistance. Any device which becomes unoperational or non-operational behaves like an insulator. So because of this, suppose 5 ampere current was coming, so this 5 ampere current passing through the bulb, this will pass, but fan will not allow it to pass. Because of that, circuit will not be completed and no device in the circuit will be operational. Okay, so what happens? If any of the devices in series, if any of the devices fail, all the devices in the circuit become non-operational or unoperational. Okay, they will not be working. So if at your household you have connected everything in series, AC, fridge, okay, 10 bulbs, fan, etc. Suppose any of the bulb got fused, your entire connection will be gone. Would you like this? You will not like this. Why? Because the electrician will come, he will just check every device, which device was gone, which device was gone. Every time you will need to call an electrician for the purpose. But at present what is happening? If any of the device, okay, if any of the device is not working, you are able to check it by your own, because only that device is non-functional, other devices are functional. That is why at households parallel connection is used. Is preferred. Now see, again suppose this fan also stopped working. So this will offer you infinite resistance at your friend's house also. So see what is happening. 5 ampere current came, current will go to this direction, but this will not allow it to pass. So entire 5 ampere current will pass through the bulb because there is two route. Okay. So that is why here if one device is non-operational, other device will be working. You can understand this like example. Suppose this is your house is having only one gate and few goons are waiting for you in front of your house. You came to know, so what will you do? You will not go to your house, you will stay at any hotel or your friend's house because goons are waiting for you and there is only one entry gate, so you will be beaten. Here goons are waiting for you at the front gate, but your device is, there is two route, right? So your house is having two gates, so you will get backdoor entry. So that is why two entries are good. Who knows? Emergency door, emergency exit. So understanding this or not, that in parallel, if one device is gone, other devices will be operational. That is why it is used at household. Series is used at Diwali lights, etc., where you are not very much interested. Okay, these are temporary things. Okay, parallel connection will be bit costly because wire cost, etc., increases. So that is why you go there. With this, we have to do the concept of fuse. Have you seen the fuse? So what is fuse? Fuse is a device, okay, that is used to save your costly electronic appliances. Suppose this is your voltage source and this is your suppose household. So bulb is added, AC is added, refrigerator is added, fan is added, washing machine is added. Suppose everything is added and everything will be added parallel, right? So parallel connection is there. This is your suppose household connection. This is how. And this is your voltage source. So every device, every electronic device will have a limit, of capacity of holding particular amount of current. Suppose your AC can hold up to 25 ampere of current and because of voltage fluctuation you got 30 ampere of current. So what will happen? Your AC will be gone. So that is a very costly thing that you can afford. If every time the voltage fluctuation is there, this is not good for you, right? So what we do for unexpected voltage fluctuations, we just add fuse in series. Okay, so we just add fuse in series. So what happens? If unexpected current is coming, fuse will melt. There is a wire in the fuse. Okay, just see this. This is older version of fuse. So there is a wire here. Okay, so this wire melts. Because of that, the circuit is broken and current is not allowed to pass through the circuit. So here it will melt and circuit is gone. And if that is the case, current will not flow further. So fuse is added here in series so that it can break the circuit. The fuse is what? First is, it is a device to protect costly electronic appliances. From unexpected voltage fluctuations. Okay. This is like your army or defense forces, okay, who sacrifice their lives so that the civilians can be safe. So what they do? They sacrifice their lives. So they sacrifice themselves so that the connection is broken. So that unexpected voltage or current coming is your terrorist, and fuse is the defense force, and these appliances are the civilians. So fuse will sacrifice itself in order to stop the intrusion of that unexpected current or the terrorist. Okay, this is what is idea. So fuse is used in series. Just think about the defense forces. Okay, if parallel connection will be there, it means there will be more than one route. Okay, so at border you will not like many porous points from where the terrorist can enter. There should be only one or two so that they can have their visual, their eye on them. Understanding this? So it should be added in series. This is first thing. Second, there is a wire, I told you. That wire melts, so melting point of the wire should be low. Why melting point of wire should be low? Because if it will be high, all devices will be gone and fuse will remain there. Means there should not be self-love for the defense personnel. He should have a sacrificing attitude. That is how they are trained also, and they do their job very well. So melting point of the wire should be low, because if it will be high, then fuse will not melt and entire devices will succumb to that fluctuation. And third is, resistance of the fuse should also be low, because if resistance will be more, so what will happen? Energy loss. You will not like to pay 5 units of electricity bill for fuse. Okay, Kejriwal offers only 200 units for free. So you will like to harness that benefit, right? So that is why these are the properties associated with the fuse. Okay. So let's take a very small break, maybe 4-5 minutes. Then we will start with effects of current. Okay, after the break. Okay, let's meet after the break. Let's resume with heating effect of current. Okay, effects of currents, we will be looking for different effects. For example, heating effect of current, chemical effect of current, etc. So let's start with heating effect of current. Just remember the concept we have done before the class, before the break. The concept was that any conductor is going to offer you resistance, right? And that resistance with time leads to the heating of the conductor. So that heating of the device is nothing but wastage of current or wastage of energy. Okay. So that wastage of energy, if can be harnessed to our benefit, that is a golden opportunity to save energy. So that is what is done. For example, we use it in our heating devices. For example, heater, for example, geyser, iron, hair straightener, etc. So the devices which use heat work on the principle of heating effect. So to increase the heating effect, we are using nichrome coil. Are you able to see the nichrome coil there in the circuit? So that coil is made up of nickel and chromium. Nickel and chromium alloy is nichrome. So nichrome coil is used in these devices. Okay. So please write about heating effect. There is nothing much in this. Please write. With the passage of time, with time you write, with time, conductor offers resistance, which leads to heating of the device, Write further here, which leads to heating of the device. Here electric energy is getting converted here, the electric energy is getting converted into thermal energy or heat energy, whatever you write, into thermal or heat energy. An alloy of nickel and chromium, an alloy of nickel and chromium, in bracket you write nichrome, the spelling is on the PPT. An alloy of nickel and chromium, in bracket you write nichrome, is used to intensify the heating process, to intensify the heating process, Write further. This property of current is utilized in heater, geyser, etc. Next is chemical effect of current. Give heading chemical effect of current, then whatever I will be doing on board, write it. Have you ever seen that if geyser is non-operational, the electrician comes and he says that we need to change the wire. Okay, there is a coil sort of thing. It is found in your geyser, in your heater, in your iron, etc. So that coil he is talking is nichrome coil. Okay, that we need to change the coil. The coil is non-working. So that is the nichrome coil he is talking about, the heating effect. Okay, so have you given the heading chemical effect? Now whatever I am doing on board, write it parallelly, because I am just dealing with the basics. After completion of the basic, we will understand chemical effect of current. So first the basics. Solution. Solution refers to solute plus solvent. Okay. Solvent solvent means what? Solvent means like your water, solute like your salt. This is like your water. Sugar plus water, salt plus water, anything that will lead to solution. Solution is of two types. First is your electrolytic solution, and second thing is your non-electrolytic solution. Electrolytic solution means on passage of current, ions are formed. Okay, on passage of current, ions are formed. This is your electrolytic current. That is, such solutions allow passage of current. Okay, such solutions allow passage of current. So on passage of current, ions are formed, and such solutions will allow passage of current. Okay, so it means, example, your potable water or any water you are having, HCl, anything, whatever you want to use, sodium chloride, anything, sodium chloride solution, anything. So potable water, etc. So what is here? That if current is passed, suppose there is current carrying wire that is put in the swimming pool. So any person on that end of the swimming pool will also feel the shock of the current. Why? Because the water will be conducting electricity. So this sort of solution will be doing same. Electrolytic will be just opposite. Salt will be there, but they will not be broken into iron. So the example of this is distilled water. So ions are not formed in distilled water. Hence, it does not conduct electricity. Okay. So this property of current is known as chemical effect of current. So chemical effect of current is applicable only to the electrolytic solutions, not to the non-electrolytic solutions. Okay, that if current passes through electrolytic solution, ions are formed, because of that electricity is conducted by that solution. This is known as chemical effect of current. So leading to the discussion, so chemical effect means what? I am just rewriting it. So chemical effect means what? Breaking into ions. What is ion? Ion means what? Charged particle. So from here I am taking discussion forward. Ions, ion means what? Charged particle. So charged particles either can be positive, sir, or this can be negative. Either it can be positive or it can be negative. If it is positive, the term used is cation, positively charged, and if it is negative, the term used is anion. So cation being positive will go towards negative electrode. What is electrode? You will come to know just within few minutes. First write. And anion will go to positive electrode. So this negative electrode is known as cathode, and this positive electrode is known as anode. Okay. And here you write one more point. Electroplating is one of the manifestations of chemical effect of current. What is this? We will discuss. First copy this. You will understand everything. Copy this. Okay. Now just see, breaking of the solution into ions is called chemical effect of current. So ions will be either found positive or negative, so cation and anion, and hence they will go to the respective electrodes. This process is known as electroplating. So electroplating is one of the manifestations of chemical effect of current. So electroplating means what? Electroplating is process of accumulation of one metal on the surface of other metal. Okay. Means you can put zinc over iron, means iron is plated with zinc. Sometimes there is a called, okay, we will first discuss here. For example, you wanted to gift someone special on the eve of 14th Feb, right? You understood what I am talking. So you wanted to discuss a gold jewelry, provided the lockdown has impacted everyone and the prices of gold has escalated. So you can clearly understand that your pocket will not allow you, provided you are a student. So you went to Tanishq and asked them for gold jewelry. They said that it will minimum cost you 30,000 rupees. And when you just checked your pocket, it was around 8 to 10,000 rupees. So you felt very sorry that you can't offer the same. So Tanishq said you one thing, that we can do one thing for you, okay, that we will give you a jewelry of silver, but it will appear like gold. You became very happy. Means they offered you for imitation jewelry. It will appear like gold, but it will be of silver. Okay, everything is dikhawa today, so showmanship will be there for you. So just see this, what they do in this, they just put silver, suppose it was silver jewelry, there is a silver spoon, so silver jewelry here and gold one here. So this gold, which is the metal which is to be plated on this, is kept at positive terminal. So this is a positive electrode, so it is known as anode. Just check your notes. And the metal on which you are, it will be made negative electrode, that is your cathode. Okay. So electrode is, negative electrode is the metal which is to be protected, and anode the metal to be deposited. Okay. So cathode is, I am just defining the electron, these are metals. This is the metal to be protected or plated, both are same thing. And anode, this is metal to be deposited. This is also known as sacrificing metal, because this metal will melt from here and this will travel through the solution. This metal will melt from here, this will travel through the solution and will deposit upon this silver metal. That is why it is used as term sone ka pani chadhana. So no saline is inserted, it is this the process of electroplating. So the solution is also kept of gold, for example gold chloride, because this is going to melt. So this has to travel through the solution. That is why the solution is made up of anode. So solution will be of anode solution. So what I am trying to say, the metal which is to be protected is made cathode, and the metal which has to be deposited is made anode. That is why it is known as sacrificing metal. So this process of accumulation of one metal, so this can be done for dual purpose. First is your imitation jewelry. or second will be protection of important metals. For example, iron, etc. Heavy appliances are made up of iron, but iron is prone to corrosion. So imitation jewelry, for example, gold plating on silver. So in this case what will happen? Gold will be made anode, and since silver is to be kept at bottom, so silver will be made cathode, as we saw. Production of metal, some terms are there, for example galvanization. Galvanization means zinc plating on iron. Means zinc will be made anode because zinc has to, and iron will be made cathode. So this is what is your chemical effect of current. So please copy that diagram also, whatever is written there, that will help you. I will give you 2-3 minutes, copy that diagram first, then copy this concept. This concept we have copied, just the electroplating one. Okay, have you written? Just write this one also, the electroplating. Okay, so this is how anode will react during electroplating. So anode during electroplating will be like this or not? Yes. Now let's move to another effect of current, that is generator effect or dynamo effect. So what is dynamo? Dynamo or generator? Just write in one line, then I will make you understand. Just write in one line. Dynamo or generator. Generator, you know the spelling. It is a device that converts mechanical energy into electric energy. This is a device that converts mechanical energy into electric energy. So what is meant by this? Actually, see, in nature you will not find electric current. Okay, in nature you will have water current, in nature you will have heat current. Okay, current means what? Flow of anything. For example, water is moving from a waterfall. So water has more energy stored in it because it is coming from a greater height. In physics terms, potential energy is converted into kinetic energy. So water is coming from great heights, right? So it is going to hit you somewhere. So water is having some energy. So that energy needs to be harnessed. So that energy is in the form of mechanical thing. Okay. So there is a turbine is kept. So turbine starts moving. So that turbine is having now mechanical energy. Mechanical work is getting done. So that work needs to be stored. So for that, dynamo or generator is used. So dynamo or generator will always be there at your power station, at your windmill, at your sea energy installations, at your nuclear power plant. So wherever you are having a power plant where you need to store electricity, generator will be the device that will, or dynamo will be the device that will store or convert the mechanical energy into electrical energy. Okay, so this is what is the idea. And there is a twin device of this, motor. So motor is at your home, everybody is knowing motor, what is motor. So motor is a device that converts electricity into mechanical energy. Just write this, then I will make you understand. It is a device that converts electrical energy into mechanical energy. That converts electrical energy into mechanical energy. Electrical energy into mechanical energy. Now just see, if there is no electricity at your house, what you do? And there is a well. So you just pull out water from well. Okay. So you have to do some mechanical work or not. You have to use your energy while pulling out water out of the well. But if electricity is there, motor does that work. It pulls out water from the well to the pump, to the tank, right? It pulls water out of the well to the tank. For this, motor utilizes electric energy or not, because without electricity it cannot work. So what it is doing, your mechanical work was supplemented by the motor with the help of electric energy. So that is why it is converting electrical energy into mechanical work or mechanical energy. Understood this? Okay. Now, very important, inverter. So before we deal with inverter, again some basics, you are expected to copy it from board. Okay, some basics, then we will do inverter. So first let's understand AC versus DC. Suppose this is the graph where I am showing voltage or current this side, and this is the parameter for time. And there is another graph where I am showing voltage or current this side, and again time here. And this is what is the current. So in first case, if suppose this is 1 second, this is suppose 2 seconds, this is suppose 3 seconds. So at 1 second there is some magnitude of current, at 2 seconds it is 0, 3 seconds it is negative. But for this, at 1 second it is some value, 2 seconds it is having similar value, 3 seconds it is having similar value. So this current is known as alternating current, that we call AC. This is fluctuating current. Means value changes with time. Okay. This is known as direct current or DC. This is your constant current. That is, current will not change with time. DC is older version of current. AC is only 125 years old, only around 125 years old. But DC is the oldest current we are having. So now we are shifting to AC. Most of the devices nowadays are use AC because of its efficiency and other characteristics. So you understood, if the current will be changing with time, okay, in terms of magnitude or polarity, anything, it will be known as AC current, else it will be known as DC current. Some more differentiation let's have. So AC current and DC current we have seen, changing with time, not changing with time, etc. So there will be some devices, those used AC current. Okay, so AC currents also use some devices. For example, all your household appliances, not every household, means whatever will not be written here will be here. So household appliances like refrigerator, air conditioner, etc., they will use AC current. Transmission lines. Transmission lines you see on road, 3-line wire. So what they do? They carry current from power station to household. So these transmission line also use AC current from power stations to household. So these are major applications of AC current. If you see DC, DC is nowadays not having too much application, but there are some important points that you need to remember. I am telling you. First is, battery will always give DC. If you remember this line, this is a thumb rule. इसको याद कर डाला, लाइव झिंगा लाला, that sort of thing. So battery will always give you DC, and apart from that there are some loyal devices of DC. For example, mobile. For example, plasma TV or television, laptop, e-vehicles, etc. So these are the loyal devices. But if you see, complete separation or compartmentalization is not possible, because suppose e-vehicles are there. For example, metro is also a kind of e-vehicle. Okay. So India's oldest metro, which is India's oldest metro? Kolkata Metro. So Kolkata Metro uses DC current. Very fine. India's most advanced metro, the Mumbai Metro, it also uses DC current. But India's most efficient metro, that is Delhi Metro, it uses AC current. So it is not always strict, but in general DC will be the prevailing factor. Okay. Now let's understand what is inverter. Suppose inverter is there. So inverter is a combination of two things. One is your battery and other is your device called inverter. And suppose this is your household appliances, for example air conditioner, fridge, fan, anything. Okay, these devices are there. Suppose electricity is there, so battery will be getting charged. Yes or no? Battery will be getting charged. If electricity is gone, this battery will power your house or not? This battery will power your house, but this battery uses DC current, and suppose these appliances, these are in parallel, okay, and these appliances, they will require which current? AC current. Just see under AC, I have written household appliances, they generally use AC current. So don't you think this is the duty of the inverter to convert this DC into AC, else these appliances will not work. Battery hai, so battery will always give DC, and inverter has the ability to convert it into AC, else other appliances will not work. So inverter is nothing but device which converts DC into AC. I hope you are understanding this, because battery is going to give you DC and your household appliances will work on AC. So there should be some exchange medium or not. That is what is written. Copy this. Board पे रखो. Try this question. Okay, I have got few answers. Vikram and Sandeep. Yes, you both are right. Very good. Vikram Singh and Sandeep Kumar Yadav. Chhava Triveni. Very good. You are also right. I will look after one or two more responses, then I will explain. Any other response? Utkarsh Chauhan, yes, you are also right. Option A is the right answer. Okay, you all people have gone for right response. Now just see, the question is about fuel cells. So I don't know, I have not taught you, okay, no issues. If pure hydrogen is used as fuel, then the fuel cell emits heat and water as byproduct. We are not having the idea of this, no issues. Fuel cells can be used for powering buildings and not for small devices like laptop computer. Again, this seems to be slightly confusing, no issues. Fuel cells produce electricity in the form of alternating current. This is the line where I can think. Now they are saying fuel cell is giving you alternating current. Cell is nothing but battery. Battery is nothing but collection or accumulation of cells, not the cell taught in biology. Okay, the cell, have you heard 8 cell battery, 12 cell battery means what? 12 cell battery is more powerful, 8 cell is having less power. Okay, cell is the accumulation. That is why a battery company name is also Duracell. You must have heard. So this is nothing but collection of cell. If you have broken this, then battery will give you AC? Never. So this statement is wrong. The third statement is gone because battery will never give you AC. So if third is gone, rest others are gone. 1 is the answer. Now just see, fuel cell means battery, replace it by battery. So battery can be used for powering building, okay, it can be used, and not for small devices like laptop. What I told you, DC, any battery devices are laptop, plasma TV, mobile. So this statement is also wrong. Yes or no? If you have broken this, that fuel cell is battery. Now the third one is, first one is pure hydrogen is used, fuel emit, yes. So there is hydrogen that will take oxygen from the atmosphere to give you water, and the process is highly exothermic. Exothermic means heat will be released. So this is what is the first statement, that is no harmful emissions, only energy is there and water is formed. So that is why only one statement is correct, others are not right. Now magnetic effect of current. I need your focus on the board for the next 10 minutes. I will make you write this. Okay. We will not understand magnetic effect of current as you have understood in your school days. I told you my purpose is only the application, okay, and making you understand without touching the technical details of the things. Okay. On that premise, let's understand what is magnetic effect of current. So for the next 10 minutes, pay attention, do not write anything. I will make you write the definition, etc. Okay. Suppose there is a current carrying wire. Suppose there is a current carrying wire. So this current carrying wire has magnetic field developed around it. If you want to remember, your father or anybody must have warned you in your childhood that never go near the poles, because the wire carrying current have a strong magnetic field, they will catch you towards you, right? They will attract you and you will be dead. Okay, so there is a fear among the children about this. So what is there? That this electric current flowing through the wire is producing magnetic field. Is it clear? It is producing magnetic field. It was observed that if a conductor is brought in the magnetic field of this wire, if any conductor is brought near the magnetic field, conductor may be particularly iron, is brought near the magnetic field of this wire, this conductor gets magnetized. Okay. If a conductor or iron is put near the current carrying wire, it gets magnetized. Understanding this? That is, it behaves like magnet. That is it, behaves like magnet. I repeat, if there is a current carrying wire, so magnetic field develops around it, this is natural. But if we bring any conductor, particularly iron, near this magnetic field, it gets magnetized or it behaves like iron. Okay? Behaves like magnet, very sorry. Now suppose this electric flow is stopped. So now what we are doing, electric current is stopped. So if electric current is stopped, definitely no magnetic field will be there. No magnetic field will be there, magnetic field is gone. So we find that the magnetization is also lost. We also see that conductor loses its magnetism. Means the magnetism of the iron or conductor is only for the time till the electric current is passing through the wire. If electric current is not there, magnetic field or magnetism in the conductor is also not there. So this property is harnessed to make electromagnets. So electro means electricity, magnet. So magnet, these are temporary magnets. Temporary magnets which work upon electricity only. Right? So these electromagnets have a lot of application. For example, in telephone receiver. Okay? In telephone receiver, electric bell at your house. And apart from that, apart from electronic devices, these are also used in particle accelerators. I will name a few. So if you find these are particle accelerators like Large Hadron Collider, LHC. Big Bang was proved because of this. Cyclotron, Betatron. So these are particle accelerators. So particle accelerators do nothing, they accelerate the speed, the velocity of any particle, for example proton, electron, etc. Okay. So this is what is electric effect of current. So I request you to first write this, then we will talk. Write about this. When current flows through a wire, first write, then I will give you the time to copy if you want. Right. When current flows through a wire, a magnetic field is developed around it. When current flows through wire, a magnetic field is developed around it. Next, when an iron rod is brought near this magnetic field, when an iron rod is brought near this magnetic field, comma, it gets magnetized. it gets magnetized. It gets magnetized. Next, right? When the current flow is stopped in the wire, when the current flow is stopped in the wire, flow is stopped in the wire, the magnetic property is also gone. The magnetic property of iron is also gone. When current flow is stopped in the wire, the magnetic property of iron is also gone. This property of current is harnessed to develop electromagnets. Which are used in various electronic devices, in bracket you write telephone receivers, electric bell, etc., which are used in various electronic devices such as telephone receiver, electric bell, etc. Right further, such electromagnets are also used in particle accelerators. The names are written, copy that. Such electromagnets are also used in particle accelerators. Copy the names. Large Hadron Collider, Betatron, Cyclotron, the names are there. So suppose the speed is 20 kilometers per second, suppose I am saying, and you want the speed to be 2000 kilometer per second. So these particle accelerator will, accelerate them. They will move them in circles or loops. Because of that, speed will increase. So that is why it is known as particle accelerator. Now I will make you understand this, okay, so that whatever we have written, some more clarity is there, okay. So I have taken rough picture of electric bell. Do not consider that electric bell is going to be asked in your examination. I have done it so that magnetic effect of current is clear in your head, because magnetic effect of current will have many applications. For example, maglev, that is the train, that is the metro of Mumbai. So if current developments etc. will be there, you will be able to understand it, right? I will not touch those topics because I do not have time and liberty to cover those things. Just see, this is a rough circuit. This is a rough circuit of your electric bell. The circuit is divided into two parts. The left part, it means that this one, okay, this part will have electric flow. Means electricity will flow only through this part. This part will remain isolated, that is again an iron rod. So this part is also iron rod, but here electricity will not pass. So when you press the switch, electricity is going to pass through this part only, not through this part. Is it clear? This is iron rod in which a hammer is attached and there is a gong. So this is iron rod in which a hammer is attached. These are again iron rods in which wire is twisted. So these two blocks you are finding are also iron rods in which wire is twisted. So when we press the switch, okay, while pressing the switch, what happens? Current flows through this wire. So when current flows through these wires, because of that, these two get magnetized. Iron in the vicinity of magnetic field. So suppose current is flowing, right? So don't you think magnetic field will be there? And these iron rods are in the magnetic field itself. So they get magnetized. So they behave like electromagnet. So this iron rod, this is also of iron, will get attracted towards these two electromagnets. So if this will get attracted, this is attached. So this hammer will be also shifted this direction, which will hit the gong and you will get ting tong. I repeat, when you press the switch, current flows through these coils. Because of that, the iron gets the magnetic field and it behaves like electromagnet. These electromagnet will attract this iron rod and hence the hammer, which is going to hit the gong to give you ting tong. So this is what is your magnetic effect of current that I made you. Now electromagnetic induction. Okay, this was given by Faraday. So what is electromagnetic induction? Let's understand. That diagram was not required, electric bell. That is why I am not giving you time. Only for your understanding I have explained that. So Michael Faraday. So we will understand the personality of Michael Faraday, okay, because induction is a big thing that makes you, that is really difficult to understand. So I will make you understand in a simple way. I hope it should work. Let's understand the personality of Michael Faraday. Okay. So Michael Faraday was the view that if I am offering, this is Mr. Faraday, if I am offering rose to a lady, lady should also give me rose. Wow. Problem of the life is settled. If you like someone, just offer the rose and she or he should give it back to you. How easy it is, right? So this was the view of Michael Faraday. Let's shape his theory of his personal life in his scientific development. So he said that as electric current, just remember, electric current was offering me magnetic field, yes or no? So as for Mr. Faraday, magnetic field should also offer electric current. This was seen, evident, this is natural, this happens, but he wanted this, which was not happening. For this, he just made a circuit. So suppose this is iron rod again, coiled with wire, and there is a device. Yes, this is solenoid I am making, Ashish. A solenoid also works upon magnetic effect. This is what is solenoid, a twisted cable. But we are not interested in solenoid etc. like of things. Okay, those things are bit typical for a physics student, not for the general science. So galvanometer is there, and yes, this device is solenoid you are talking about. So what he did, he made a circuit like this. So iron was there and it was twisted with a cable. Okay, and galvanometer. Galvanometer is a device to detect current. So if there will be current in the circuit, it will be detecting it. And there is one more device, ammeter. It is a device to measure current. So there is a difference. This device will only show you whether current is flowing or not. This device will give you the measure of the current, means magnitude of the current, whether 2 ampere is there, 3 ampere is there. So that is the difference between these two devices. So he used galvanometer and he put a bar magnet in front of the device. So he put a magnet here. Why? Because magnet will have its magnetic field or not. So he has put this in a magnetic field and he is expecting electric current to come. Like electric current was giving magnetic field, so he has put the entire system in a magnetic field and he is waiting for electric current. Okay. Nothing happened for months. Faraday visited many of his companions of the time, okay, and he made many circuit, everything, but nothing worked because his thinking was not right. If I am giving rose to a lady should also give me back. One day out of anger, what he did, it was lunchtime, he was hungry. So out of anger he just took the magnet and threw it. Accidentally, the magnet traveled through the circuit. It was accident, okay, accidental eureka was there. So he threw the magnet and accidentally it moved through the circuit and the galvanometer deflected. That day Michael Faraday learned lesson of life. So will you. Like when magnet was moving through the circuit, so don't you think first magnet was here, then the position of magnet will be here, then position of magnet will be changed, then it will be here. Yes or no? Magnet will be changing every moment. So magnetic field will through this conductor or solenoid you are talking will be changing every second, and hence galvanometer deflected. So that day he learned that magnetic field will not give you electric current, changing magnetic field will give current, because when the magnet is moving, the magnetic field near the conductor is also changing. So changing magnetic field give you current. So if you are giving rose to a lady, lesson for you people, you want that lady should also offer you a rose, put some efforts. Try. You will definitely get. Okay. It doesn't mean go to a married woman. Do not do that. Okay. So this is what is this. Means changing magnetic field will offer you electric current. This is what is electromagnetic induction. So first we will write this, then we will understand the applications. Right. It is the production of electromagnetic induction, right? It is the production of voltage or electric current, voltage or electric current in a changing magnetic field. In a changing magnetic field. Right further. Applications are wireless charging, ED currents, etc. Applications: wireless charging, ED current, etc. ED current, etc. After changing the paragraph you write, we will discuss on this. ED currents are loops of induced current, in a conductor. ED currents are loops of induced current in a conductor in a changing magnetic field. ED currents are loops of induced current in a conductor in a changing magnetic field. This current is often seen as heat loss. as heat loss, but have applications in induction cookware, melting of metals, train braking mechanism, etc. So first understand that how wireless charging is working. Few years ago, company named Samsung said that we will give you a pad, you need to add this pad to the circuit and you need to put your mobile on this pad. You need not plug your mobile will get charged. Means you need to just put your pad in the charging. No need to put any plug in the mobile gets charged. How it was possible? When current was coming, so current entered the pod or pad, you say pad, okay, current entered. So don't you think this current will produce magnetic field in the pad? So this current will produce magnetic field in the pad. So just see this, current in pad will produce magnetic field in pad, okay, and mobile is in this pad only. So mobile will be in this pad only, no? It will be put in this magnetic field. So mobile is under this magnetic field. Now just see, the current entering here is AC. So AC is what? Changing current. So we are having changing current in pad. AC and DC we have seen the definition. So if changing current is there, we can expect magnetic field to be changing every second also. So changing magnetic field will be there in pad, and hence mobile is in the vicinity. So what will be there? Changing magnetic field produces electric current. So electric current will be produced in mobile. Yes or no? I repeat, since it was changing, because AC current is coming, so changing current in the pad produced changing magnetic field, and changing magnetic field will induce electric current. So this mobile was kept in this magnetic field which was changing. So electric current in mobile will be there and mobile gets charged. That is why it is called wireless or inductive charging. That is why it is called wireless or inductive charging, because no wire is involved. Next is eddy current. If you see, this is a conductor. If it will be kept in a magnetic field, so circular loops are formed. Okay, these loops of current are known as eddy current. Okay, bhavar, like eddy. So circular. So eddy currents have application. For example, cookware. So these lead to heating effect. Okay, so heating effect is generally seen as loss. So we find it for our purpose. For example, cooking, induction cookware is there, right? And melting of metal, etc. Apart from that, train braking mechanism. Do not ask the entire mechanism, that will be difficult for me to tell you because other concepts are involved. So if you see the wheels of the train, so there is a jack here, okay, and this is the wheel. So suppose wheel is moving in this direction, and when brakes are applied, since it is circular currents will be formed. So eddy currents are formed in the jack, which in opposite direction. So eddy currents in jack. So if you apply brakes, So eddy current in jack in opposite direction. Because of that, it jams the wheel and train stops. So this is the braking mechanism. बोर्ड पे रखो. Okay. Now we will see some abnormal behavior of water. So the first one is about latent heat. So just write latent heat definition. Latent heat. Right. Latent heat is heat absorbed or released by a substance during phase change provided the temperature is constant. Provided the temperature is constant. Okay, let's understand this. It is bit tricky to understand, but we will try to. For example, when ice is converted into water and water is converted into vapor. So this is solid form, this is liquid form, and this is gaseous form. So this is called phase change, that if ice will be converted into water, that will be a phase change, because from solid to liquid it is getting converted, right? Is it fine? So that is phase change. Suppose ice is there and it is getting converted into water. So some heat is provided to it. So ice is at 0 degree, it is getting converted to water, but here the temperature is again 0 degree Celsius. Your head should think that since it is gaining some heat, temperature should rise. But up to certain limit there is no change in temperature. Up to 80 calorie. For example, if you provide ice up to 80 calorie, it will be getting converted into water, but temperature will remain constant. Now if you provide 81 calorie, means just 1 calorie extra, temperature here will just rise and here it will be 0. What is the idea? This 80 calorie here is latent heat. That this heat will not be reflected in changing the temperature. Okay, this heat will only do the purpose of phase change. Okay, so this heat not have any contribution. In temperature change. Right? Not have any contribution in temperature change. But it will be involved in phase change. Actually, it breaks the hydrogen bonding in water. What is hydrogen bonding? We are not interested to understand that concept, but you have to understand this one, this will have nothing. You can understand latent heat is like black money. Tax officials are knowing that a huge amount of money is earned by that particular person, but a particular sum is not reflected in the balance sheet. Because of that, tax is evaded. So this is like black money. The client should have paid tax to the government, but he is hiding it. In the same fashion, this 80 calorie is being hidden because the temperature here is exactly 0. Nothing change will be there. Another example I will give you. Suppose water is getting converted into vapor. Up to 540 calorie, the temperature of both will be 100. So this is your boiling water, which is getting converted into vapor. So temperature here is 100 and here it will be 100. But no change in temperature. If it is 541 calorie, then you will find slight change of temperature, suppose 100.001 degree Celsius. So this 540 calorie here is latent heat, means up to 540 calorie nothing will be reflected in temperature. But take it from me, this will be more hot. Okay, vapor means your steam. For example, if you are cooking something, for example if you are cooking rice etc., so you first boil water. So when you go to put off the lid, your mother says please do not do that. Okay, if you are doing it, do it carefully, because steam can burn you more. Why steam can burn you more? Because though steam is also having 100 degrees Celsius like the boiling water, but steam has additional 540 calorie heat. Though it is not reflected in temperature, but it is there. Like black money, though not reflected in the balance sheet, but that money remains with that particular person. Is it fine? So that heat will be there with it. So in latent heat example application, you can write here applications. First application you can write here, steam can burn you more severe than boiling water. Okay, as steam is having 540 calorie of latent heat, though the temperature is 100 degrees Celsius. This is first application. Okay, you must have heard this. Okay, copy that. Other applications are waiting. Now second application you see, suppose you are having a bottle of Coke, okay, though it is not looking like Coke, but consider it. So you put it in the vicinity of ice. you put it in the vicinity of ice and it gets cooled after some time. So ice while melting, though will share the same temperature, will absorb 80 calorie. So ice will absorb 80 calorie every ice crystal. Okay. So this 80 calorie will be observed. The temperature of this water will be at 0 and this will become cooler. So while something gets cooled if kept in the vicinity of ice, this is because ice while melting absorbs some heat, है ना, keeping temperature at 0 only. So this is the second application. Third is, suppose your mother, she is cooking something, so she asks you after putting off the flame, go and take your vegetable after 5 minutes. Why she says so? Because in this case your vapor or steam are at the bottom of the lid. This steam is having additional 540 calorie in them. So when they will condense, so they will go into your food, so they will put 540 calorie in the food and food will get cooked even after putting off the flame. So food gets cooked even after putting off the flame, or cooking process is there, putting off the flame, as steam while condensing release 540 calorie in food. So please copy this. Okay. There is one question, Utkarsh, is eddy current also used in regenerative braking? Regenerative means something is regenerating. Means suppose if something is decelerating, means the speed is declining. So regenerative braking will have energy recovery mechanism. Means it will convert that kinetic energy, okay, and it will try to accompany the battery, etc. Okay, means it is a kind of storage thing. Eddy current is kind of losing some sort of energy. So regenerative braking, as far as I know, is using generator. Okay, but since torques, etc. are involved, I can't be very sure of eddy current in this, but a generator is used in that case, because it has to convert the energy. Regeneration means it is storing some energy. So generator, I have taught you the dynamo, so that will convert the energy. I can't be sure of eddy current in this case, because the energy story is there and eddy current is on the opposite side. So my logic would say very less chances, okay, but I am not very sure of. But this sort of thing I would not say that should be required, because it is highly advanced technology and way back actually. But yes, generator will be used. So dynamo will have its application because storage of energy is there. Okay. So have you understood this applications we have written? So this is your latent heat. We'll proceed from this particular slide in the next class, that abnormal behavior of water at 4 degrees Celsius. So we will proceed from this, and we will be covering surface tension and Archimedes principle. 2 more concepts of physics are left, and then we will start with chemistry, like radioactivity, alpha decay, beta decay, gamma decay, etc., various states of matter, etc. So we will cover from this in the next class. Thank you.